So of the people listed in this chapter, I think Kepler and Galileo are my heroes. Actually, Alexander the Great is pretty cool too. But, excuse me, what Galileo needed to resolve, no pun intended, and he did, were some hang-ups to the geocentric model of looking at the Earth and the other planets orbiting the Sun. One of them is if the Earth is moving, that as it moves, it's gonna leave its atmosphere behind. So, and we know that we need to breathe and have a sense for our air. Our air would be left in a trail behind us. It seems kind of strange, doesn't it? And there's this thing called, basically it has momentum, and it's going to stay in the direction it's moving unless acted upon by a different outside force. The other thing that he kind of came up with some good ammunition for is this whole circular thing. Remember, Kepler said that the planets don't orbit in a circle; they orbit in an ellipse or an oval, and so that was one thing. But the other thing is, I guess I would say, Galileo worked on the whole perfection thing. You know, that nature is perfect. Well, nature has some interesting twists. It's wonderful, but it's not perfect. And then the other thing about stellar parallax, the thing that if the Earth is moving, we should see the stars change their relative position, kind of whichever's closest, whatever's farthest away. Okay, so with regard to the first one, the fact that if the Earth is moving, then it's going to leave behind its atmosphere. He did some simple experiments, and he showed that an object that is in motion will stay in motion unless acted upon by an outside force. Now, the reason Aristotle thought that an object in motion will eventually come to rest is because objects in motion eventually do come to rest here on Earth. But the force acting on them is, there's a few, but the major ones would be gravity and friction. So Galileo said as long as there's no other force acting on it, that object will stay in motion. That would include the Earth and the atmosphere around the Earth. Okay, it has a certain amount of momentum in a certain direction. So the whole thing about the circle is perfect. Wait, the heavens are perfect and a circle is perfect, therefore the heavens obey the whole circular thing. Well, what Galileo pointed out is that actually Tycho Brahe, looking at the stars, observed what is called a supernova event. And right then and there, basically what a supernova is, it's a couple things. Basically, it took what a star used to be there. It's a star blowing up, okay? And I can't remember if it's type 2 or type 1A. But there was a light, okay? It gets real bright, and then the light basically is gone. So the heavens change. The heavens aren't perfect. The other thing is Galileo used his telescope. He didn't invent the telescope. He used the telescope to look at celestial objects. And he actually, and I'm not quite sure how this works, but he actually could see the disk of the sun, and he could see it marred by sunspots. And, you know, we see those same sunspots today. They go through cycles. A lot of sunspots, not many sunspots, a lot of sunspots. Okay, and he observed that. So the sun's disk was not perfect. And then last but not least, he used his telescope to look at the moon, and he could see that it was not the same. The moon's surface has pocks. They're beautiful pocks. They're beautiful craters. It has kind of blotchy areas called mare. You know, the moon's not perfect. So why when we come up with a model of how the planets orbit the sun, would we make it have to be in a perfect circle? With regard to parallax, so again, it has to do with the telescope. So he took his telescope and looked at the Milky Way, which, if you get a chance, or maybe you've had a chance to look at the Milky Way, the band that goes from horizon to horizon, where you're looking into the galaxy, the plane the plane of our Milky Way galaxy. That's what the Milky Way is. So when you look at it, actually with the telescope, you see instead of it being kind of milky, there's like stars galore, okay? And that got him to thinking to kind of put in perspective the distance of these objects. And he's like, you know, these objects are way far away, and objects that are way far away like that show no parallax. And sometimes I tell students, for instance, the two people looking at a tree against a mountain, okay? What if you were to take that tree and not make it nearby, but put that tree on the mountain, okay? And then kind of be the woman and be the man, okay? Be the man, okay? And actually you would see that tree now is part of the background, and you don't see any parallax. So, yeah. So Galileo also used his telescope to, that circle right there is the planet Jupiter. And those things that look like stars actually are the moons that orbit Jupiter. And this is so cool. This is why scientists keep lab notebooks. What a famous page from his lab notebook. Okay, so actually there are, Jupiter has more than just 4, but there were 4 that he could see actually with his telescope, and reflecting light from the sun back to him, or back to us. So there are 4 famous moons around Jupiter called the Galilean moons. They are awesome. So I guess the point there is there's got to be more to all of this if even that planet can have moons, right? That planet can have stuff orbiting it. The other thing is that you kind of see this figure at the top here. This figure, kind of from left to right, if I were to ask you what it reminds you of, you might say full moon, waning gibbous, quarter moon, crescent moon, and a crescent moon. Okay, waning crescent. And honestly, those are, if Galileo saw Venus in those different phases. I'm not sure if he really saw the full, but I'll show you how, since Venus is Venus is a planet that orbits the sun, just like this figure shows, closer to the sun than the Earth. Okay, we're actually going to see it go through phases. So just to kind of emphasize some things, if we go ahead and leave the Earth stationary, and here's the path that Venus takes as it orbits the Earth. Okay, right here, when Venus is between the sun and the Earth, okay, the lit part, the lit hemisphere of Venus is, we can't see it. So that's the new phase. And then we see it orbiting counterclockwise, okay, and actually then when it's in a position maybe over here, we see just a sliver of the illuminated hemisphere. That would be this one. Okay, then we see it continue to go around, and actually when it's at a right angle, now I know I'm keeping the Earth where it is, and the Earth should be moving too, but just bear with me. If we go ahead and keep the Earth at a right angle from Venus, actually here, then you're going to see a quarter of it, and it's going to look like this, right? And here we're going to get more and more illuminated. And here it's going to get larger, so it's waxing and it's a gibbous. But do you see where I don't quite know if you would see Venus in a totally full phase? Because to see Venus in a full phase, you need to have Earth, Sun, and Venus on the other side. And that's kind of a tricky thing. Okay? It seems like there was something else I was going to say. Oh, I don't know. Maybe not. But that's very cool. The other thing your author does, though, is over here on the left, you see with the geocentric model, putting the Earth in the center, okay, and having everything orbit the Earth. So here we have the sun orbiting the Earth. It's kind of strange. And here we actually have the path of Venus orbiting the Earth, okay? So the thing about this model is that if you have even if you have Venus doing like little epicycles, you will not end up ever seeing a full Venus or anything beyond a quarter, quite frankly. So, I don't know, you can prove that to yourself. So, the story of Galileo, I think what strikes me too is There are biographies out there, and I think his daughter wrote an autobiography. And it was a sad situation in that his heart and passion was in science and understanding and explaining his observations. I just think he was a cool dude. He might have been the Neil deGrasse Tyson of back in the 1600s. I don't know. But his proposal that heavens are not perfect, proposal that, you know, things in the heavens are not perfect, actually contradicted the thinking of the Catholic Church at the time, and he was a staunch Catholic, as I understand it. And so that's all kind of sad. But in 1992, the Church, he was vindicated. So thank you, Galileo.